So first of all, I'm going to create a ground plane. So let's go to my Create menu. And what I might use is under the Environment menu, I might create a floor. Now a floor is an infinite plane. It looks like a square in our scene. It actually extends infinitely in all directions, and that'll be good for my ground plane. So the next thing I'm going to do is just create a cube, and let's just bring this up in the air a little bit. And let's set up some rigid body dynamics. So there's two main types of rigid body dynamics. And we access those through the tags menu. And down here in the menu, we've got simulation tags, and we've got a rigid body. And the other one I'm interested in is the collider body. So what we've got, a collider body, let's start with that one. I'm going to put a collider body on the floor, and I'll explain what that does. So I've created a collider tag on the floor. What this means is that this object will take part in dynamics collisions. Objects will collide with it, they'll bounce off it, but it will not be affected by any collisions or forces itself. It's just an object that is participating in the rigid body simulations. So it's a really handy type of rigid body for creating boundaries around your simulations, for representing objects that won't be moved. And the good thing is with collision bodies is we can animate these moving around. I'm going to do that in a second after I've tested out my cube. So that's a collider body. Now this cube, I want this cube to fall from the sky and bounce around. I want it to be affected by gravity. Gravity is turned on by default in Cinema 4D scenes. So I want to make this into what's called a standard rigid body, which will be affected by forces as well as collisions. So I'm going to select my cube, go to Tags, Simulation Tags, and add a rigid body tag to it. So there's the two different tags, collider body, rigid body. Now if I hit play, my cube falls and it bounces. Brilliant. So that's a simple dynamics situation working, where we've got a rigid body affected by forces falling down and hitting the collider body, which is the floor. So that's great. That's super simple. That's easy to deal with. So what are the things that we can do now that we've set that up? One of the main things that you'll probably use is collision and friction and bounce. So let's go to the cube, and let's say we want this cube to be really light and springy and like a ping pong ball that bounces around. So I'm going to select my rigid body tag. I'm going to come down to the collision tab, and in here two of the settings I've got are bounce and friction. So I can turn the bounce up way up. So what I should get now is a really big bounce when that cube hits the ground. Yep. It's flying off in all sorts of crazy directions. Now, this is spinning and bouncing off because there is a little bit of collision noise. Collision noise creates a slight amount of randomness when two objects collide. Another way I can change the way that this cube interacts with the floor is just by rotating it around a little bit. Oh, I need to rewind. That's one really important point when you're dealing with rigid body simulations, is that the computer calculates them in real time. You can't scrub through the timeline. You won't get an accurate representation. And also, if you try and move rigid body objects when you're at any frame other than 0, pretty much nothing will happen. So the great thing about rigid body dynamics is that it can simulate really complex behaviors of bouncing and collision and things flying around. But the limitation is that it kind of operates in real time. You have to set up a simulation and let it run, and you don't get as much fine control over tweaking every little bit of animation on every single object. So let's just rewind that, and then I should be able to reposition the cube in its initial state. So I'm expecting it'll bounce off in some crazy direction because it's going to land probably on its point. There we go. And let's just make this a little bit more interesting by putting a couple of other objects in here. So let's create a sphere. And let's just bring this up in the air a little bit. Maybe make this one a little bit bigger. And what I'm going to do with this is put a rigid body tag on this one as well. Simulation tags, rigid body. So now what I should expect is these two both fall and then maybe collide with each other once they've hit the ground. Yep, not super exciting. But we could make this a little more interesting if we go to our sphere, go to its rigid body tag, and in this collision tab, maybe I'll make this thing really bouncy. So let's put its bounce up to 80%. So now we should get a bit of bounce. Not much bounce because the cube is hitting it. So let's just shift my cube up a little bit higher in the air and see what this does. Okay, not super bouncy. The other thing we can do, I've adjusted the bounce on the cube and the sphere. The floor as a collider also has its own bounce and friction settings. Now, the bounce and friction are set at 100% for this collider. Obviously, we can change these. You can put the bounce value above 100%, which will make it unnaturally bouncy. And anything bouncing, let's just extend my timeline here. Anything hitting something that has a bounce level of above 100 will get unnaturally more and more bouncy. So let's just see what happens with this cube and sphere. So the cube's gone flying. The sphere is actually starting to bounce even higher, which is not very natural. So that is because this value is above 100%. Okay, so there's just some really simple introductions to the rigid bodies and the collider bodies, and one of the basic functions, which is the bounce and the friction. Friction will really come into play when objects start sliding across a surface. Okay, so that's a quick introduction. So one thing that is really important about simulations as well is that when you have many objects in a simulation, it can be really taxing on your computer. So there's a couple of shortcuts that the computer does to try and speed things up a little bit. And I'm going to demonstrate one of those. One of them is to do with the shape of objects in simulation. So I'm going to delete my sphere, and I'm going to create a torus, which is a donut shape. So here's my torus. Let's just bring that up, and I'm just going to make this a little larger. And I'm going to grab my cube and just bring my cube down so it's just above the torus. Okay, there we go. So what I'm going to do now is I'm going to make my torus a rigid body so that it will bounce and collide with the floor and the other cube. Simulation rigid body. Now what we would expect to see is the cube will fall into the middle of the torus and bounce around the cube. The torus, actually, let's just lift that off the floor. That'll bounce down and hit the floor a little bit. So that's what I'm expecting to see. So let's have a look when we hit play and see what happens. Okay, that's not quite expected. What we've got is the cube sitting on top of the torus. So what's happening here is the shape that is being used to calculate the dynamics. What Cinema 4D by default does is that rather than calculating the absolute exact surface of any object, it creates a temporary or stand-in shape that roughly represents this. Now the stand-in shape tends to be either a bounding box or a sphere around an object, and it takes the widest and tallest and the deepest parts and creates a stand-in low-resolution box or sphere around that to calculate the rigid body dynamics. So what that means is this torus is appearing to the simulation as an actual cube. It's not understanding that there is actually a hole in the middle of the torus. So with objects that have holes in them or have a very uneven surface, we need to do something a little bit different with this shape value. Rather than just using an automatic default box shape or sphere shape, what we want to do is actually change it to a moving mesh. Now, we can use a static mesh as well, as long as there's no deformation going on or the object isn't moving at all. It's probably a little bit safer or slightly more reliable result by using moving mesh. So let's rewind now, hit play again and see what happens. Okay, the floor is still super bouncy, which is why the cube's gone, but that's more what I was expecting to see. The cube is actually falling inside the torus now. So that's one thing that's really important when working with irregular objects, or especially ones with holes. Make sure to change that shape to either static or moving mesh. You can test these, see which one works best, but those are really important. Otherwise, as I said, Cinema will use a bounding box shape. Okay, so let's just create a couple of other objects here. Make another cube, and let's make another torus, and let's make this one quite large but thin. And let's put it slightly to one side and just see what happens with this. Now, with this one, let's make sure that we put a rigid body tag on it and change the shape to moving mesh. The cubes, they're very simple. Let's just keep those with the standard settings. And now we've got that thin torus settling over the top as we'd expect it to see. Okay, so that's a really basic introduction to the simplest parts of rigid body dynamics. Rigid bodies themselves, which as I said are affected by gravity and forces and collisions, and collider bodies which are not affected by forces, but they will take part in rigid body simulations.